the Phoenix Automatic Filter Pneumatic Model. We will first familiarise ourselves with the principal components. The 3-inch ANSI 150 inlet flange and discharge flange. The differential pressure switch with its high pressure and low pressure connections. The over-center V-band clamp. The 3/4 inch backwash ball valve and actuator. And finally the indexing actuator, whose function we will look at in more detail shortly. Let's now look at the fluid flow paths in more detail. Dirty fluid enters the central column via the inlet flange. It then enters each of the 6 filter pods via the inlet galleries. The flow into each pod is tangential to impart a spin to the entering fluid. This turbo action serves to keep the debris away from the filter element, thus extending the time between backwashes. Any debris which is larger than the micron rating of the element remains on the outside. We will see how this is removed by backwashing shortly. The cleaned fluid now passes through the filter element and up into the donut cover, where it joins with the flow from the other 5 elements. This common filtered fluid exits the filter via the discharge elbow and flange. To understand how the backwash process works, let's take a partial section through the filter. Now we'll rotate the backwash shoe into the position it would be in to backwash pod 4 in our sectioned view. We can now see that the face of the shoe has completely obscured the pod inlet gallery so that no fluid can enter. However, the vertical slot presents a new flow path for a small proportion of the common filtered fluid to pass down the inside of the filter element, flushing the accumulated debris into the shoe, up into the body of the indexing valve, along the 3/4 inch backwash pipe, and away to atmosphere via the backwash valve. Staying with our sectioned view, let's take a closer look at the inner parts which drive this backwash process. We will follow the drivetrain down from the indexing actuator itself. We start with the upper drive shaft, whose double D profile locates in the indexing actuator drive spindle. Next come the upper and lower 7-toothed dog clutches. The spring maintains a contact force between the 2 dog clutches while still allowing vertical movement of the upper drive shaft. The lower drive shaft has a protruding screw which, in the position shown, depresses the roller arm of the home position roller valve. The function of this roller valve is to tell the control system that the filter's home position has been found. The lower drive shaft passes through the body of the indexing valve and is connected to the shoe in the inlet tube of the filter. We have returned the shoe to its home position, where it is not obscuring any of the rectangular inlet galleries to the 6 filter pods. We can also see the lower drive shaft retaining circlip. And finally the thrust bearing which takes the upward fluid pressure load. Let's take a closer look at the backwash process by following the motion at half speed. First, the indexing actuator rotates 90 degrees counterclockwise and the dog teeth ratchet up and over each other. After a short pause, the indexing actuator rotates 90 degrees clockwise and the dog teeth engage. In this way, the lower drive shaft is rotated through 1/7 of a revolution. Notice also how the home switch roller arm has dropped down off the protruding screw, telling the control system that the indexing valve is no longer in the home position. Let's look at the process once more, this time closer to real time, and backwashing pod 2. Ratchet back, pause, drive forward, pause. Backwash valve open for the duration set in the control panel, backwash valve close. To complete the backwash cycle, we will follow the action for pod 6. Ratchet back, pause, drive forward, pause, backwash valve open, close, pause, and then the final drive to the home position with feedback to the control system from the home roller valve.